In this media, you will learn how to troubleshoot closing control scheme of a circuit breaker. Let us consider a circuit for local mode of closing the breaker for troubleshooting. Troubleshooting of the scheme starts from supply lines. Before starting the process, the closing coil of the breaker must be isolated electrically. This is because when the closing command is given, the closing coil 52C gets energized in a fraction of a second. The closing coil is usually short time rated, that is, it is designed to withstand supply for fraction of a second only. While troubleshooting, there is a possibility for the closing coil to be in energized condition for a longer time. For example, if anti-pumping relay is not healthy or if there is some other internal problem before tracing the fault, the closing coil may get damaged. Thus, it is always safe to isolate the closing coil from the circuit while troubleshooting. Assume the supply voltage is 220 volts DC. Measure the voltage between K1 and K2 lines and check for the availability of supply. Check whether the fuses are healthy. To check the HRC fuses, remove them from the circuit and measure the resistance across the fuse terminals with the multimeter range kept in low resistance mode. If the multimeter is kept in high resistance range for checking the fuse conditions, the multimeter may show continuity even if the fuse has blown off, since any traces of molten fuse element inside HRC fuse tubes may give a low resistance path across the fuse terminals. This is why the multimeter should be kept in low resistance range and the fuse should positively show 0 ohms across the fuse terminals. In some cases of defective high rupturing capacity HRC fuses, the resistance across the fuse will be more. The fuses should be replaced if they fail the above continuity test. Assume that all fuses are found normal. The L/R switch should be checked for healthiness. The L/R switch contacts may be pitted or the connected wires may have burnt due to local heating. The healthiness of the L/R switch is found by measuring the voltage between K23 and K2 lines. If the switch contacts are found normal, then voltage drop can't take place across them. Hence, the multimeter shows full supply value. If the switch is not healthy, some voltage will drop across the switch and so multimeter shows less value than supply voltage. From that, you can identify and rectify the problem in the switch. Assume that the L/R switch is found healthy. Next, TNC switch should be checked for healthiness. It is done by turning the switch to closed position momentarily and measuring the voltage between K211 and K2 line. If the switch is healthy, the multimeter displays the full supply voltage. The multimeter shows voltage less than that of supply when the switch is not healthy. Assume that TNC switch is also found normal. Anti-pumping relay 95 and its contact 95-1 must now be checked for healthiness. Apply voltage to the coil by turning the TNC switch to close position momentarily and check if the relay picks up. If the relay coil 95 is found healthy, check its contact 95-1. Measure the voltage between K17 and K2 lines. If the contact is damaged or pitted, voltage will drop across it. Hence, the multimeter shows voltage less than that of supply voltage. Assume that anti-pumping relay and its contact are found normal. The limit switch should be checked for healthiness. This is done by checking for the full supply voltage between K15 and K2 lines. If the limit switch is found good, the contact 52B should be checked for healthiness similar to 95-1 contact. If contact 52B is found good, check the closing coil for its designed resistance value. If it is also okay, check the coil mechanism for any mechanical sluggishness and fix it. If the coil mechanism is damaged, replace the whole trip coil assembly and test the circuit. Thus, you have learned how to troubleshoot closing control scheme of a circuit breaker.